Most SQL learners know about foreign keys, but few know about how to fine-tune what happens to a record that's being referenced when you perform a data delete or update. Let's fix that. In this video, we'll cover the foreign key constraint and the referential actions. By the end, you'll have a deeper understanding of how to use foreign key constraint effectively in implementing database designs. In case if your memory on foreign keys become vague, a foreign key can be thought as a link between two related tables. A foreign key is simply one or more columns in a table that reference the primary key of another table. The two tables are of course related. For example, think about the database supporting an online store named the Sci-Fi Collective. There are two tables in this database, and they are related to each other. One table represents products sold by the online store, while the other table represents product reviews. The product table uses the product code as the primary key, and the review table uses review ID as its primary key. The two tables are in a one-to-many relationship. The foreign key is in the many side, or say the review table. That makes the product table the parent table, and the review table the child one in this relationship. The same review table is also related to the user table in the database. User table uses the email column as the primary key. The relationship between user and review is another one-to-many relationship, in which the review table is on the many side. So the foreign key email goes into the review table. That makes the user table the parent one and the review table the child one in this relationship. As you can see, the review table contains two different foreign keys. This is common in database design. How do you translate the design of foreign keys, or say the review table into SQL code when it comes to implementing your database design? The recommended approach is to name the two constraints and define them individually, like this. The keyword constraint allows you to name a constraint. The definition of the foreign key constraint starts with the foreign key keyword. After that, you need to wrap up the target foreign key column in a bracket. After that, you need to specify which primary key is referenced by this foreign key via the references keyword. It will be followed by the related table and its primary key. The primary key goes into another bracket. Does the foreign key constraint do anything? Of course. If you try to insert a new row of review data into the review table, but references a non-existing user, SQL will complain and stop you from doing that. Similarly, if you are trying to delete a user from the user table, but that user is referenced by several rows in the review table, you will be stopped. Or if you are trying to update the primary key value of a user who is referenced in the review table, you will also be stopped. That's the power of the foreign key constraint. However, that may not be what you truly want to happen when it comes to deleting or updating a row of data in the parent table, like user or product. Sometimes, when we need to delete or update a row in the parent table, we want the referenced row in the child table to be deleted as well. Or sometimes, we want to keep those rows in the child table, but make the referenced foreign key value to be set to null, so that data integrity of the tables can still be maintained. Is that something that can be done in SQL? Yes, that's where referential actions come into play. So what are referential actions? Referential actions are about handling what happened to all the related rows in the child table when a referenced row in the parent table is updated or deleted. For example, think about the product and review table. In this relationship, the product table is the parent table, and the review table is the child table. When you need to delete or update the primary key of a row in the product table, but it happens to be referenced by many rows in the review table, You can specify whether such an action is allowed or not, and what should happen to the rows in the review table that references the particular product you want to delete or update. There are 3 types of referential actions that are commonly used, including restrict, cascade, and set null. Let's talk about each of them one after another. Restrict prevents any modifications or deletions of a parent record if dependent child record exists. For example, the database will throw an error if you try to delete a product row who is referenced in the review table. Restrict is the most conservative approach that helps prevent accidental data loss. You may see that I put no action in a bracket right by restrict. Restrict and no actions are actually 2 different types of referential actions, but they behave almost the same. No action also stops any modification or deletion of parent records if dependent child records exist. The only difference between the 2 is timing, which doesn't matter much here. So for simplicity, we will think them as one type of referential actions. When you create a foreign key constraint, either restrict or no action is used by default. That said, as soon as you create a foreign key constraint and don't do anything extra, restrict or no action is already enabled. Of course, you can also choose to be more explicit about it. That requires you to use 2 clauses, onDelete and onUpdate. OnDelete is the clause that defines the referential action type when a parent record is deleted. OnUpdate is the clause that defines the referential action type to use when a parent record is updated. Both need to be followed by some referential action type. Such clauses need to be placed in the definition of your foreign key constraints. That's everything about the most conservative type of referential action. However, it may not be what you want to happen. In some cases, you want your delete or update query to be executed on the parent table, and that requires the help from other types of referential actions. Cascade. If this referential action is chosen, when a record in the parent table is updated or deleted, the corresponding change will automatically propagate to all related records in the child table. For example, if you delete a product, all the referenced reviews are also going to be deleted. This maintains a consistency, but can also result in widespread data loss if not used carefully. If this is what's required by the business logic, you need to specify it accordingly when it comes to defining your foreign key constraint, like this. The cascade should follow the onDelete and onUpdate clauses, and they should be placed in the foreign key constraint definition. Just for the record, onDelete and onUpdate are totally independent, and they don't have to take the same type of referential actions, and everything is up to the business logic. For example, if you want to use Cascade to handle all updates, but don't want delete to happen in the same manner, you can go with Cascade for the onUpdate clause, but restrict for onDelete clause, like this. The third commonly used referential actions is setNull. If this referential action is used, when a parent record is deleted or its key value is updated, the foreign key values in related child records will be set to null. As you can imagine, this would require the foreign key column to allow null values. For example, if setNull is used as the referential action type, when the product record is deleted, any review rows that reference the product record will have their product code value set to null. To use this type of referential actions for delete, setNull should follow the onDelete clause in the corresponding foreign key constraint. As you can see from this example, onUpdate is followed by Cascade, which handles the modification in the parent table differently from the deletion. In this video, we covered what the foreign key constraint is and how referential actions work. If you find this video helpful, give it a thumb up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deep into database design using real-world examples. You'll find the link to the book in the first comment.